Today's notes are going to be on 4.1, solving system of equations by graphing. Now, solving a system of equations is a set of two or more equations that use the same variables. A linear system is when the graph of each equation in a system of two variables is a line. Now, this is important. The solution to a system of linear equations occurs where the lines intersect. So there's three different cases. Here is line 1, here is line 2. Well, right here, this is intersecting lines, which means they have one solution. So the point where they intersect, the x is 1, 2, the y is 3. So the point of intersection here is going to be a 2, 3. Now, one thing I notice about these is that the slopes are different from one another. So the slopes are different, which means they will intersect each other at some point. And then on the y-intercept, although the y-intercepts are different, it really doesn't matter because the y-intercept could be the same exact thing because that could be the point of intersection. So your y-intercept doesn't matter. On this second graph, you only see one line. Well, technically, that's equation 1 and equation 2, which means it's the same exact line. So this is the same line. This is called coinciding lines, which is infinite solutions. Now on here, your slopes have to be the same and the y-intercepts have to be the same as well. And on this last graph, here's equation 1, here's equation 2. I notice that they're parallel lines. So they are rising at the same rate and running at the same rate. So right here, your slopes have to be the same, but the y-intercepts, they must be different. They must be different. All right, now we're going to get into some solving a system of equations by graphing. So these are the three different types of graphs. We always want to make sure the equation is in y equals mx plus b form so that we can graph. So for equation 1, I'll go ahead and I'll graph this one in red. Right here, that is in y equals mx plus b form. So the m is going to be a -1. Keep in mind, the m is always the number in front of the x. And the b is going to be the number 3. Now, this is going to be your x-axis, and this is your y-axis. So right here, you always want to graph the slope, the y-intercept first, which is the b value. So the y-intercept is going to be 3. So 1, 2, 3. And now my slope, always make the slope into a fraction. If it's not a fraction, make it a fraction and throw the negatives on the top. If the number is positive, you go up. If the number is negative, you go down. And the number on the bottom always goes to the right. So in this case, I'm going to make it a fraction. And because it's negative, I'm going to go down 1 and then 1 to the right. So starting at your y-intercept, I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1. I like to draw more than 1 if possible, just so that I can draw a straight line. So that's equation 1. Sometimes when you're connecting two dots, you might go a little bit off. I'm going to go ahead and graph this one in blue now. On this case, the m, here's mx plus b. So in this case, the m is going to be a positive 3/2, and the b is going to be a -2. So right here, my y-intercept is going to be the -2, so -1, -2. And then my slope, because that's a positive 3, I'm going to go up 3, 2 to the right. So up 3, 1, 2, 3, 2 to the right. Up 3, 1, 2, 3, 2 to the right. Up 3, 1, 2, 3, 2 to the right. Now I'm going to connect my dots, and that's equation 2. As you can see, right here is the point of intersection, and that is the coordinate x is 1, 2, y is 1. So right here we have one solution, and that is the coordinate 2, 1. So that point makes both equations true. There's only one point that will make that a true statement and that a true statement. So that's the point makes both equations. Okay. On the next one, if you notice, that isn't not in y equals mx plus b form. So what I'm going to do is I'm going to take the 3x plus y equals 5. I need to solve for y, so I'm going to go ahead and I'm going to subtract 3 to both sides. So if I subtract 3 to both sides, I'm left with y equals negative 3x plus 5. Now you can put the negative 3x in the back, it doesn't matter. The m is always the number next to the x. So the m is going to be the number negative 3, and the b is going to be the number 5. I'm going to make the m into a fraction. So now I'm going to go and I'm going to graph this. I need to graph the y-intercept first. So 1, 2, 3, 4, 5. That's the y-axis. And then from the y-intercept, I'm now going to go down 3 over 1. So down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. And then I'm going to go ahead and connect my dots. Equation 2, once again, that is not in y equals mx plus b form. So I have x minus y equals 7. I need to go ahead and I need to minus the x to both sides. If I minus the x to both sides, I'm left with a negative y on the left side. Do not lose that negative. Negative y equals negative x plus 7. I still cannot graph that. The y needs to be a positive. So what I'm going to do is I'm technically either multiplying everything by -1 or dividing by -1. I'm going to change every single sign. So the opposite of negative y is positive y. Opposite of negative x is positive x. Opposite of positive 7 is negative 7. So now I can go ahead and graph this. Now there is an invisible 1 here, you just don't see it. So the m value is a 1 because that's the number next to x, and the b value is a negative 7. Now I need to graph negative 7 first because that's the y-intercept. So here's negative 1, 2, 3, 4, 5, 6, 7. And now my slope, that's a positive, so I'm going to go up 1 over 1. Up 1 over 1, up 1 over 1, up 1 over 1, and connect my dots. I have a point of intersection. That is right here. And that is x is 1, 2, 3. So x is 3. Y is 1, 2, 3, 4 down. So that's going to be a negative 4. So once again, I have one solution. And that point is what makes both equations true. Now I want you guys to hit pause and I want you guys to try these on your own and then hit play. I'm going to go ahead and I'm going to solve them now. That's equation 1. My slope here, I'm going to throw the negative on the top. Now m doesn't always have to be in the front, but m is always the one next to x. I'm going to graph my y-intercept first. So 1, 2, 3. My slope goes down 5 over 3. 1, 2, 3, 4, 5, 1, 2, 3. 1, 2, 3, 4, 5, 1, 2, 3. And it helps to always draw your line so you know which one is which. Y equals m x, and then b is going to be a negative 3. Negative 1, negative 2, negative 3. My slope goes up 1 over 3, up 1 over 3. I do have a point of intersection. And right there, the x is a positive 1, positive 2, positive 3. And then the y is going negative 1, negative 2. So that is my only solution to this system. Once again, that does not say y equals mx plus b. So if I have 2x plus y equals negative 4, I need to solve for y. So I'm going to go ahead and I'm going to subtract 2x to both sides. So y equals negative 2x minus 4. In this case, the m is going to be a negative 2 and the b is going to be a negative 4. You always have to graph the b first because that is your y-intercept. So the y-intercept is at negative 4, negative 1, negative 2, negative 3, negative 4. And then the slope, I'm going to make it a fraction. And because it's negative, I'm going to go down 2, 1 to the right. So down 2, 1 to the right. I can't go down 2, 1 to the right, but I do notice it's going like this. So I can actually go up 2, 1 to the left and figure out the other points just so that I can draw my line straight. This is equation 2 now. This one, it is in y equals mx plus b form. Here, m is equal to 1/2, b is equal to 6. I need to graph my y-intercept first, so that's going to be a 6. 1, 2, 3, 4, 5, 6. And then the slope positive means up 1 over 2. So up 1 over 2. I can't go up 1 over 2 again, but I could go down 1, 2 to the left. So that I could draw my straight line. And there's my point of intersection right there. That is x is -1, -2, -3, -4. And then the y is +1, +2, +3, +4. So I have one solution there. Solving a system of equations with infinite many solutions or no solution. Remember, no solution is when you have parallel lines. Infinite many means it's coinciding lines. It's the same exact line that you're graphing because one's on top of the other. My first equation, my y is not solved. It does not say y equals mx plus b. So if I take x minus 2y equals -2, I'm solving for y first. So I need to minus the x. So that is going to be a -2y equals -x minus 2. Now be careful right here because when you're solving for y, you're going to go ahead and you're going to divide everything by a -2. Now, there is a 1 here, you just don't see it. So right here, when these cancel out, I'm going to be left with y equals a negative, and a negative is going to make that a positive. And then right here, that's actually 1/2 x. 2 is the denominator, 1 is the numerator. That is going to be 1/2 x. And then right here, a negative and a negative makes that a positive, and 2 divided by 2 is 1. So on equation 1, your m is going to be a +1/2. The b is going to be a +1. You have to graph the y-intercept first. So here's the y-axis. My y-intercept is going to be at 1. And then my slope, because that's positive, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. This is equation 1. Equation 2 is already solved for. So that says y equals, right here, the m is going to be 1/2. The b is going to be -2. So your y-intercept is going to be at -2. So -1, -2. Slope is going up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. And if you notice, your lines are parallel. Going back to equation 1, the m was 1 over 2 as well, up 1 over 2, but the b value is different. So these ones right here are parallel lines. So these are parallel lines, which means they will never cross each other. This right here is no solution. Same slope, but different y-intercepts. So when I ask why, it's because they are parallel lines. They don't intersect. Parallel lines have the same slope, but different y-intercepts. Example 2b. Once again, y is not solved for. So I need to go ahead and I need to just minus 2x to both sides. So if I minus 2x to both sides, y is equal to -2x plus 4. So right here, the m is going to be a -2, the b is going to be a +4. I need to go ahead and I need to graph the y-intercept first, so that's going to be a +4. 1, 2, 3, 4. And the slope is going to go down 2 over 1. Make sure you guys are using a straight edge On equation 2, I have an x plus 1/2 y equals 2. I need a minus x to both sides. If I minus x to both sides, I get 1/2 y equals negative x plus 2. Now, I need to get rid of that 1/2. So what I'm going to do is, because that is being multiplied, you can multiply by the reciprocal or just multiply by 2. If I multiply by 2 to everything, because even this side has to multiply by 2, I end up getting the 2's cancel. I'm left with a y equals negative 2x plus 4. Where your m right here is going to be a negative 2, and the b right here is going to be a positive 4. I need to go ahead and I need to graph the y-intercept first, which is going to be a 4. 1, 2, 3, 4. And then the slope, that's going down 2 over 1. Uh-oh. I notice that my dots are all lining up. It's on the same exact line. So the blue and the red line are on the same line. Therefore, this one is infinite many solutions. And why? Because they are coinciding lines. They are the same exact line. Now go ahead and hit pause. And I want you to try 2A and 2B. And then hit play and see if you graphed them correctly and got the correct answer. I'm going to go ahead and start solving them. Right here, if I have 3x minus y, that's still not in y equals mx plus b form. So 3x minus y equals negative 4. I need a minus 3x to both sides. So I have a negative y equals negative 3x minus 4. Then y cannot be negative, so I'm going to change all of my signs. So that's going to be a positive y, positive 3x, positive 4. So right here, my m is going to be a 3 over 1. My b is going to be the number 4. So 1, 2, 3, 4, my y-intercept, up 3 over 1. I'm going to go down 3 over 1 this way. On equation 2, right there, the m is going to be a 3 over 1, and the b is going to be a negative 1. My y-intercept is at negative 1, and then it's going to go up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1. And as you can see, the lines are parallel. So because they are parallel, this is going to be no solution. They will never cross each other. They will never cross each other. On 2b, right here, my m is going to be a 2 over 1, and the b is going to be a negative 3. So negative 3, negative 1, negative 2, negative 3, that's my y-intercept. And then my slope goes up 2 over 1. On equation 2, we have a 4x equals 2y plus 6. I need to move the 6 to that side, so I'm going to minus it. So that's 4x minus 6 equals 2y. And then if I divide everything by the number 2, so I get the y by itself, 4 divided by 2 is going to be a 2x. 6 divided by 2 is going to be a 3, and that equals y. So your m right here is going to be a 2 over 1. The b here is going to be a negative 3. I need to graph the negative 3 first. And then the slope is going to go up 2 over 1, up 2 over 1, up 2 over 1. And as you can see, it's the same exact line. Same slope, same y-intercept. So that right there is going to be infinite many solutions. Because they are coinciding lines. Hope you got those right. Write a system of equations. Manisha and Holly are both reading a novel that is 220 pages long. Manisha has read 96 pages and plans on reading 9 pages every day. Holly has read 6 pages and plans on reading 20 pages each day, every day. So I have a feeling you're going to have to get the 20 has to be multiplied by the number of days. Right here, the 9 is going to have to be multiplied by the number of days. Write a system of equations that models a situation and determine when Holly will catch up to Manisha. So right here, I'm going to go ahead and I'm going to let X equal the total number of pages read. And I'm going to let Y equal the number of days. So on this one, when I do Manisha, I'll do her in red. It's going to be her total number of days. Well, let's see. Hold on. 9 pages every day. Oh, wait. I think I need to switch my variables. Yeah, I think I need to switch them. Because time is always going to be independent. So actually, this is going to be Y. And this is going to be X. Time is always going to be on the X-axis. Time is always going to be on the X-axis. So right here where it says Manisha, that's going to be, let's see here. Manisha is going to be 9 pages every day, and she started at 96. So the total numbers of pages she read is going to be the 96 plus the 9 per day. Holly read 6 pages and 20 pages each day. So I'm not sure if that is the graph, because I think I did it the other way around. But no, that is correct. That is correct. I could show you guys on Desmos to show you that that is correct. On Desmos, if you type that into Y1 and type that into Y2, if you zoom out, that will be your answer. So right there, keep in mind, this is the X, this is a Y. X is the number of days. So in 8.182 days, they would have read 169 pages each. So right here, it will take about 8 days for Holly to catch up to Manisha. They will both have read about 170 pages. When will Manisha finish the novel? Now, keep in mind that the novel was 220 pages, and this is Manisha. So what I need to do is I need to set 200 equal to the 96 plus 9x. So 200 equals 96 plus 9x. I'm going to go ahead and I'm going to subtract 96 to both sides. So 200 minus 96, that equals 104. And then I'm going to divide that by 9. And my answer is 11.55 days. So that's approximately 11. Oh, wait, not 200. It's 220. I'm sorry. Right here, it's 220 pages. So 220 pages equals 96 plus 9x. So I'm going to take the 220. I'm going to minus the 96. So I get 124. And then I'm going to divide that by 9. So that is 13.78 days. 13.78 days. So Manisha will finish the novel in about 13.8 days. When will Holly finish the novel? So now I'm going to set 220 equal to Holly, and Holly's equation was 6 plus 20x. So I'm going to go ahead and minus 6 to both sides. So I get 114 equals 20x. And then I'm going to go ahead and divide that by 20. So 114 divided by 20, and that equals 5.7. Let me make sure 220 minus 6 pages. Oh, wait. Yeah. And then divide that by 20. So the answer is 10.7. So right here, Holly will finish the novel in about 10.7 days. Okay, that concludes our notes, but let's go ahead and check for some understanding here. So how can you use a graph to illustrate the solution to a system of linear equations? You can graph the two and check the point of intersection. So you can graph the two linear equations. The solution will be the point of intersection. How does the graph of a system of linear equations with one solution differ from the graph of the system of equations with infinite many? Well, if it has one solution, that means that they intersect. So one solution means they intersect. They have different slopes. If it's infinite many, that means they're coinciding lines, meaning they have the same slope and same y-intercept. Why is a point of intersection for a system of equations considered the solution? The intersection point contains the x and y values that satisfies both equations. It makes both equations true. A student states that the system of equations below has no solution because the slopes are the same. Describe the error. Well, we need to actually find out what the slopes are here. So if you have y equals negative 3x plus 1, oh no, sorry, minus 1, that's a minus 1. Your slope here is going to be a negative 3. The y-intercept here is going to be a negative 1. On the next equation, we have a 3x plus y equals negative 1. I need to subtract the 3x to both sides. So y equals a negative 3x minus 1. So once again, the slope is going to be a negative 3. The y-intercept on this is going to be a negative 1. If you are comparing these two, you will notice that the slopes are the same and the y-intercepts are the same. On no solution, that means that the lines are parallel, but these are actually coinciding lines. So right here, these are coinciding lines. So this should have been infinite solutions, not no solution. So that's the error that they made. Go ahead and hit pause, and I want you guys to graph 5, 6, and 7 and check what your solution is. I'm going to go ahead and I'm going to graph them now. Here, the m is equal to 2 over 1. The b equals a 5. My y-intercept is 5, 1, 2, 3, 4, 5. My slope goes up 2 over 1. So that's my first graph. My second graph here, if you notice it says plus 0, the 0 is missing. So here the m is going to be a negative 1/2 and the b is going to be a 0. So the y-intercept is actually at the origin right here. And then it's going to go down 1 over 2, down 1 over 2. They do intersect. They intersect at x is -2, y is 1. So here we have one solution. On the next one, right here, my m is going to be a -2/3, which means down 2/3. My y-intercept's going to be the number 2. Down 2, 3, down 2, 3. On this one, if I subtract 2 to both sides, I'm left with a 3y equals -2x plus 6. And then when I divide by 3, I'm left with y equals -2/3x plus 2. So here my m is going to be a -2/3, and my b is going to be a +2. So my y-intercept's at 2, down 2/3. Okay, I notice it's the same exact line. So since it's the same exact line, that is called coinciding lines, which is infinite solutions. And then the last one, here my m is a +2/1, my b is a -5. I'm going to graph the -5 first. 1, 2, 3, 4, 5 on the y-axis. Up 2/1. On the second one, if I have a 2x minus y equals -1, I'm going to subtract 2x to both sides. So I have -y equals -2x minus 1. And then I'm going to change all my signs. So here my m is going to be a +2/1. My b is going to be a 1. So my y-intercept is at 1. And then I'm going to go up 2/1. And I notice that the lines are parallel this time. So because they're parallel, this is no solution. They will never cross each other. And that concludes our notes.